the next transformation that we need to consider are reflections. Now, as always, let's begin by supposing that we are given a function y equals f of x, which we know is going to be our parent function. And this time, let's also suppose that we have some ordered pair xy on the parent function's graph. Now, the effect of reflecting this ordered pair xy across one of the axes is called a reflection of the parent function. So let's consider the formal definitions for this. So we say that the graph of y is equal to minus f of x is a reflection of the parent function's graph across the x-axis. So another way of thinking about this is that for every ordered pair xy on the parent function's graph, we now have the ordered pair x negative y on the reflection of that function across the x-axis. And similarly, in case 2, we have that the graph of y equals f of minus x is a reflection of the parent function's graph, but this time across the y-axis. And again, a nice way to think about this is that for every ordered pair xy on the graph of our parent function f of x, a reflection across the y-axis can be thought of as the ordered pair minus x positive y on the graph of the function f of negative x. Now, here we're just considering a reflection across the x-axis as well as a reflection across the y-axis. We can incorporate both definitions and have a reflection across the origin. Now, to better appreciate these reflections, let's go ahead and consider the following example. So to better appreciate reflections of graphs, let's go ahead now and sketch graphs of the given functions. G of x is equal to the square root of negative x, and h of x is equal to minus the square root of x. Now, as always, before we begin, let's first identify the parent function associated with these two new functions, and then describe the translations of these two functions from our parent function. Now, looking at g and h here, we can see that the parent function is going to be y, or f of x, is equal to the square root of x. Now, looking at the graph of our parent function here, the square root of x, we have labeled some ordered pairs or solution points on the parent function's graph so that we can better appreciate how these ordered pairs are going to be reflected across the x-axis or y-axis. So first, let's start by thinking about the function g of x. So looking at our function g of x here, we see that x is being multiplied by a negative. So this is letting us know that we are going to, or that our function g of x is reflecting the parent function across the y-axis. So coming back to our graph, the origin here, or the ordered pair 0, 0, remains as it is, but let's think about how we can map these other ordered pairs. So the solution point 1, 1 on our parent function is going to be reflected across the y-axis to the ordered pair negative 1, positive 1. And very similarly, we have the ordered pair 2, 4 on the graph of our given function, and this is going to be reflected across the y-axis to the ordered pair negative 4, positive 2. And shame on me, we should switch the coordinates here. This is the ordered pair positive 4, positive 2. Now coming back to our reflection, if we connect these new solution points with a smooth curve, we can see the graph of our function g of x, which is defined as the square root of negative x. Now very similarly, let's now go ahead and consider the second function here, h of x is equal to minus the square root of x. Now, in this case, because we have a negative on the outside of the parent function, this is letting us know that we are going to reflect the parent function's graph across the x-axis. So coming over to our graph, again, the origin point, 0, 0, will remain as it is. But thinking about the second solution point here on the graph of our parent function, this ordered pair is going to be reflected right across that x-axis to the new solution point, positive 1, minus 1. And very similarly, for the ordered pair 4, 2, this point is going to, again, be reflected across this x-axis to the new solution point, positive 4, negative 2. And now we can connect these these three solution points with a smooth curve to see the graph of the function h of x is equal to minus the square root of x.